Hey, good morning, sixth grade remote learners. It is Wednesday, September 23rd, and I have your assignment for the next couple days. Just a programming note, you will have an assignment on Friday as well. It'll be pretty brief, but it'll actually be a quiz, a formative quiz. So nothing to get anxious about, I hope. But so far, I've been putting your scores in Power School, and it's mostly just been collected or not. And then obviously, I add comments to your individual ones. But this one will actually receive a grade on our letter scale. So whether it be E, MC, BC, AC, N, or IWS. So that will be on Friday. It'll still be a formative, okay? Not as summatives are what sort of factor into your overall report card, but it is nice to keep track of formatives as well. So anyway, on Monday, we looked at all kinds of different types of maps, and I will take a look at those because they're going to be due in about 2 minutes for you, give some feedback. But for this one, another way to gather evidence in social studies isn't just by looking at maps, but also by looking at different charts and graphs. So I thought we might go through a couple, and then there are some questions for you to answer as you go through. So one type of graph that we're going to look at is, I grew up, they were always called a pie chart, and I guess sometimes they're called circle charts now. But anytime I can say the word pie in my life, I try to take advantage of that. So I call it a pie chart, but you might hear it as a circle chart. So this is an example of one that measures the world's population in a pie chart. So the larger the slice of the pie, the more people in that country. So you can see that, well, it's hidden right now, but China is that blue pie piece there, and that would be the largest, and it takes up a certain percentage, right? That's not measuring people, that's measuring the percentage of the overall population. And there you can see some other countries as well. So that is a pie chart. It is, well, I guess that's all I have to say about it right there. If you have any questions, feel free to include them in your slide, and I'll get back to them. The next type is definitely one that you've seen before, which would be called a bar graph. So bar graphs and line graphs, which you'll see in a little bit, very similar. And sometimes they can be used, someone might choose to use a bar graph, someone might choose to use a line graph, and there's really no advantage or disadvantage to either one. Line graphs are a little bit better in terms of they can show changes over short periods of time and longer periods of time. But this one you can see is just by the monthly total of the number of visitors to Yellowstone National Park, one of our first national park out in that takes up a large chunk of northwestern Wyoming. So by reading that chart, you can see that along the x-axis, right, that's the one along the bottom that gives us our months, and then along the y-axis, that's the one that runs vertically, you can see that's measuring numbers of visitors. Always good to pay attention to your y-axis. Because sometimes, sadly, with graphs, they're not always made very well. So this one, as you can see, is made well. Every single span here is worth 100,000 visitors each month. So whenever you approach a graph, always good to pay attention to what the title is. What is this actually telling you? And then to pay attention to what is on the y-axis and then what is on the x-axis. And remember, just because you have a graph about a certain topic, that doesn't necessarily mean that the graph is going to answer that for you. The reasons why something took place, that's not going to be on here, but that might be something that you can come up with on your own. But if this question is, how do visits to Yellowstone National Park compare to say Acadia National Park up in Maine? Well, it's a fine question, but that's one that you can't actually answer with the graph that you're provided here. So graphs are great. I think they're an excellent way to communicate information, but they do have their limitations, and just make sure you acknowledge that. So questions 4 and 5 are with bar graph. And I mentioned a line graph. So this actually looks at what we call midterm elections. So presidents are elected. So say, for instance, there was a presidential election in 2000, 2004, 2006, 2010, 2000. I'm sorry, not 2010, 2008, 2012, 2016, and then of course in 2020, which is this year. So midterm elections are when we don't vote for the president, but we vote for senators and representatives. So when it says midterm elections, that's what it's talking about. And you can see here that those are those off years. So not 2000, but 2002, not 2004, but 2006, not 2008, but 2010. And it measures the voting turnout. So for instance, what this says back in like say 2014, for example, of all the people who were voting age citizens, right? So not you guys, but someone who's 18 or older like me, only 41.9% of eligible voters voted in the midterm elections. Now, granted, they're not choosing president of the United States, but think about how low that is, right? That there are way more Americans back in 2014 who chose not to vote for representatives or senators, those people who go to Washington, D.C. than did. Now that changed in 2018, as you can see, it shot up to 53.4%, but that's still just a little, barely more than half. So this is measuring in percentages. Again, pay attention to the title of the chart. What information is being shared here? Pay attention to the x-axis, and then also the y-axis, which again it's not measuring in millions here. It's measured in percentage, and it tells you right there, right below that, right below the title. So that is a line graph. Then we go to something called a climograph. So we're actually working with these with the 8th graders right now. So if you have older siblings who are working remotely, they'll know what these are. Climographs I really like because I'm a big fan of efficient use of space, which means that in just a small area, a lot of information is being given to you, and I think in a way that you can pretty clearly understand it. So a climograph, as you can imagine, measures the climate. So when we look at this climate, we're looking at precipitation and temperature. Okay. Now, what gets confusing is that instead of just being a bar graph or just being a line graph, you're actually combining the two on the same graph. They're able to do that because there isn't just one y-axis, right? Precipitation. There's actually a second y-axis over here that measures temperature. So the precipitation is in bar graph form, and you got to go to the left for precipitation. Okay, so for instance, the January precipitation is somewhere between 7 and 8 inches. So let's say it's 7.5 inches. Okay, that's pretty rainy, right? So you get 7 inches of, almost 8 inches of rain in a month. That's a pretty rainy place. The temperature is measured with the line graph. So as you can see right here, their winters, it's like, they're colder certainly, but I wouldn't say they're necessarily cold, 40 degrees in the 40s as an average temperature. Doesn't mean it's not going to get down into the 20s or into the 30s, but it also means that you're going to have some days in the 50s and 60s, even in the wintertime. And that is measured with the line graph. So for instance, if you take a look at, say, August temperature, right? Now, instead of going to the left, we actually go to the right. So we just kind of draw our finger across, and you can see that the average temperature in August is somewhere between, let's call it 67 degrees. Okay. Now, also think to yourself, does this make sense? Does it make sense that in Oregon, which is in the northern hemisphere, that the average temperature in August would be 67 degrees? Well, hopefully that does make sense. That seems to be like a reasonable answer. But for this one, I had to use this y-axis. Where people sometimes mess up with climographs is that they'll read the wrong, either they should be reading the bar graph and they end up reading the line graph, or they go to the wrong axis. So for instance, if I was looking at August temperature and I went to the left, well, then that tells me that the August temperature is 7. Well, that doesn't, August, 7 degrees, right? And keep in mind that it's not actually measuring degrees over here, it's measuring inches. So make sure your answers make sense. So this is just the example, X, Y, and Z. I filled those in just so you can see how to properly read it. But now the next one you're going to take a look at, and this is a climograph for Phoenix, Arizona. So back, still out west, but as you can see, it is much different than Eugene. So do your best with this. Precipitation measured in the bar graph and temperature measured in the line graph that is up here. Okay. And then finally, the last slide, I didn't mean to confuse you because I didn't announce it on the last one, but whenever I use sources, yes, this is not in formal MLA format, but I did want to give a shout out to where I got the images that you see. So you don't have to do anything with this. I just try to be a good model to show you that all this information is not something that I created. These are things that I found and and collected on the internet to help you guys out. All right, so good luck with those. I will this evening and tomorrow take a look at the work that you did on Monday that was due today. And then, like I said, a short quiz on Friday, which will be a formative, just like the ones that you've had, except this one will have an actual letter grade to it. All right, hope you guys have a great Wednesday, and you will see me later.